A 3 ampere current flows along the segment of wire whose path is shown in the diagram. The segment is subjected to a uniform magnetic field that has a magnitude of 6 Tesla and points in a negative z direction. What vector force is experienced by the wire shown in the diagram? Okay, so this problem is asking for magnetic force. It's given us segment of wire, current, and a magnetic field, which means that the formula we're going to use is going to be magnetic force, because we're solving for a magnetic force, is equal to the current times the cross product of the line segment and the magnetic field. So I'm going to write over here, F sub B is magnetic force, I is current, L is line segment vector, and B is magnetic field vector. Okay, next step is to look at this equation and see, okay, what does the problem give us? It says here that the 3 ampere current flows along the segment of wire, meaning that the current here is going to be 3. Now we don't know what the cross product between the line segment and the magnetic field is, so we need to find that. But before we find this, we need to figure out, okay, what is our line segment vector and what is our magnetic field vector? Okay, so let's do that. This problem states that the segment of wire's path is shown in the diagram. So this is the diagram and the path is shown, which means that if we draw a line, if we draw a line from these 2 points, it's going to give us our line segment. So we have a point 4 and negative 4 and 1 here, and 1 and 3 here. So we can draw a line from here to here. And because the line segment, the path is pointing this way, we're going to also point our line segment this way, okay? So this is our line segment, and in order to find the ijk components, which this is the component we need to find the vector, we're going to look at this line segment and see, okay, regarding to our x-axis, all right, how much does this point have to move in order to reach this point? So it's going to have to move 1, 2, 3 steps. So because this scale is just 1, 2, 3, 4, so it's going to be negative 3i. Now for our j component, aka our y-axis, we're looking at this point and seeing, okay, how much does this point have to move in order to become in this position in terms of the y-axis? It has to move up 1, 2. So it would be a positive 2, okay? And this is a negative because it has to go back, because this is 4, this is 1, so it's going to be a negative 3. So our j component is going to be 2, positive 2j, plus a line segment. Lines are 2-dimensional, so there's no z component right here, because if there's a z, it would be 3-dimensional, okay? So 0k. So this is our vector for a line segment. Now we need to find the vector for our magnetic field, so let's do that. This problem says that the segment is subjected to a uniform magnetic field that has a magnitude of 6 Tesla and points in a negative z direction. It doesn't give us the ijk notation, but it tells us that the magnitude is 6 pointing in the negative z direction. Therefore, everything else is going to be a 0. And the z direction, aka the k, is going to be in negative 6. All right, now we have our magnetic field vector. So all we have to do left here is to find the cross product of the 2. Okay, L cross B. So let's write I, J, K, set up our calculation, okay? So starting with the line segment, our I is going to be -3, our J is going to be 2, and our K is going to be 0. For our B magnetic field vector, our I is going to be 0, J is going to be 0, and Z is going to be 0, K is going to be -6. So now we need to calculate. So in order to find the I component, cover the I, multiply 2 by -6 is -12, minus 0 times 0 is 0. So this is our I. Always put a negative here before you start the J. Cover the J. -3 times -6 is 18, minus 0 times 0 is 0. This is our J. Next, always put a plus here before we calculate our K. Cover our K. -3 times 0 is 0. -2 times 0, or 0 times 2 is 0. So K is going to be 0. So now we can simplify this. -12 minus 0 is -12I. -18 minus 0 is -18J. A positive 0 minus 0 is just 0K. All right? This is going to be our L cross B. So we can remove this question mark over here and write -12I minus 18J plus 0K. All right? Now we have that. So next thing I'm going to do, I'm going to erase this part to give us more space for when we do our calculation. So we write the magnetic force is equal to 3 times -12I minus 18J plus 0K. So magnetic force is going to be equal 3 times -12. 3 times -12 is 36. This is not a -12. This is a -12. -36. Let me move this a little bit. -36I. 3 times -18 is -54 minus 54J. 3 times 0 is 0 plus 0K. So this is going to be the magnetic force vector. The unit is going to be in newtons, and here would be your answer.